So for this assignment 3, programming challenge, the assignment is to giving a different type of state table of the finite state automata and provide a string to allow the program to recognize that a program that is able to recognize if the string is recognizable. So for this assignment, to explore the different type of finite state automata, I actually picked 3 different examples to start for me to explore it. So the first example I picked is for a deterministic finite automata, which is displayed like here. The star prefix star means that it's a acceptable state. Here, the second example I picked is for a non-deterministic finite state automata. Star prefix star means a acceptable state as well here. The third example I picked is the converted type, a converted deterministic table for a non-deterministic table. So I can see that from this visualized table here, the deterministic has a for each star state, like this column here, it has a deterministic next step for each transition. So to design a user workflow, allow the user to add the transition, or in a more generic way, allow the user to add a state table. I actually designed a base class that could get instantiated with a machine type, which is either deterministic or non-deterministic. And this class will have several exposed interface methods that allow a user to add the basic key information of a state table. For example, the input symbol, the final states, the transition, and the start state. Recognize method will return whether the provided string is recognizable by the provided state table. The get table and get table converted, these two methods will show the state table that the user added to the program through the interface. So here, this is my class. My class is called FSA, which is the finite state automata. This class has a init method will initialize all the needed property inside of this class. The add input method will assign the input to the instance. Add final states will assign the final state list to the instance. Add transition will converted the provided transition, which is the lowercase f. The lowercase f structure example I listed here, it has to be a dictionary type with 3 different property. So a user will be allowed to add each transition through this method based on specific a transition type. So with that being said, I added these two checking method to make sure the provided transition function is a allowable data structure. Also, for these adding method, for this exposed instance method, I return a self at the end. So this will allow all this method can be executed in a chaining behavior. I will show in a bit. Start state will also assign the start state to the instance itself. The recognize is the method that a user can call it to provide a string of bits. And based on the instance type, I have two types here. So this has a if-else block here. So this program will be able to, based on different type of the finite state automata, and based on the provided strings, it return a yes or no as the answer. Yeah, let's move on. So for get table, this is the method is mainly for the deterministic state table. It calls the parse underscore parse, which is internal method that will parse the f map. This f map is get reassigned every time after this add transition is called. So this f map will basically get incrementally reshaped based on how many add transition methods gets called. I will show the example in a bit. This get table converted is mainly for the non-deterministic state table. Let's move on to the parse method. So for the parse method, it's basically taking in the f map, which is the transition mapping dictionary, and creates a panda data frame that can easily show the state table as my visualization tool here. This underscore convert method is it contains a recursive function which is called start convert, which is also an internal method. What it does is to convert a non-deterministic state table to a deterministic table, and parse the converted map at the end. That will assign the converted a converted type table back to the instance itself. So for this start convert recursive function here, I loop through each transition, and it has a if-else block. This block mainly is doing the checking whether has multiple next step or only one next step, which is the next state. This gen t, which is the generate transition, this function is doing the is actually combining a multiple state value to a single value. So for example, let's say for this non-deterministic state table here, the generate transition function will do for this the first transition here from from S1 to S1 S2 based on 0. This cell value will get converted to this cell value, like it will have the curly braces to indicate that it is a combined state value for converting from a non-deterministic table to a deterministic table. So yeah, so this is my whole class definition here. To test that the logic of this class is correct, I have two test suits. The first test is for a deterministic type finite state automata. So you need to instantiate a instance by calling this class, provide the machine type, and then this instance you could call the F final states at input and at start state. Those three methods are all chainable. So it's easy to you don't need to start from another line to call the method. It's convenient for a user to interact with our program. So for this test, I picked the example of this table. This table will be able to recognize a string that is ended with 0. So after I provide all the basic information from these three methods, I need to call a transition and provide the transition dictionary type. So this table has 4 rows. Each row has 2 different input symbols. So totally I need to call this transition method 8 times. And after that, I will call get table, and it will show me the parsed state table from what I have been inputted. And then I could call recognize to provide a string. So this string is not ended with 0, so it returns no. This long string here is ended with 0, so it returns with yes. My second test is for non-deterministic FSM. So for this one, similarly, I call these 3 methods here, but when I instantiate this class, I provide a non-deterministic type as the type of the finite state automata. And I call add transition multiple times to get my state table ready. Here I call get table converted. It will output the converted type. But if I do get table, it will show the initial non-deterministic table here. So in order to allow me or allow the program to recognize this string, it is more convenient that when the state table is provided, it's better at the very first place to convert this table to a deterministic type. So for any non-deterministic state table provided, this program will, when you call get table converted, it will automatically convert this table to a deterministic type. So when I provide a string here, it will be able to return a yes or no as to indicate whether the table can recognize this string. So for this table provided here, it's it can only recognize a string that with 0 or more zeros, ended with 01 or ended with double ones here. So yes, I call this one, it will return the correct response. I can make another test to combine. Let's see if we want it to be. Let's say if this one can recognize. I think this should recognize oh, recognize. Hmm? Uh-oh. Oh, maybe I need to call it again. Uh-oh.